All right, so how do we find this limit? Well, the rule at the beginning is still the same. You always do, you just plug in the x value. So what happens when we plug in the x value? We get 1 cubed minus 1 over 1 minus 1, which is 0 over 0. And see how that gives us a problem because we have 0 on the bottom? So that happens a lot with limits. And when that happens, all that means is you have to simplify it. You have to rewrite it somehow so that that doesn't happen. If you think back to pre-calculus, that's just a hole in the graph. It's like your graph is looking something like this, and there's just a hole there where it's undefined. But we can rewrite the equation to remove that hole. And that's what we need to do here. And we have to use kind of a rare method of factoring that you might not remember, that I don't totally remember. So x cubed minus 1, the difference of two cubes. Well, let's write it out actually as the difference of two cubes. So x cubed minus y cubed is x minus y times x squared plus xy plus y squared. So see how there's like no coefficients on any of those. And let's just make sure that's right, just to make sure for ourselves. So we've got the x cubed. That's what we want. And then we've got x squared y and xy squared. But then here we've got minus x squared y, and then negative y times xy, so that's minus xy squared, and then negative y times y cubed. Yeah, so that's working out. See how those cancel out, and you're just left with x cubed minus y cubed. And so that's this property we're going to use here. Notice here, this is just 1 cubed. So when we factor this, what's that going to be? It's going to be x minus 1 times x squared plus x plus 1. And that's just factoring. That like really is a rule you probably learned in Algebra 1 or Algebra 2, but then forgot. And yeah, we could definitely use L'Hopital's rule, but at this point in the course, we don't know how to take a derivative, so we're not going to be using L'Hopital's rule. But if you know L'Hopital's rule, absolutely, that is the way you should do this problem. That is the easier, quicker way to do it. But we don't know how to take the derivative yet, so we're not going to do it that way. We're going to do it this way, because see what happens now. This is a really big deal when taking the limit. You do this all the time. So you factor the top, and then once you factor the top, now you see these x minus 1s cancel. And now that we've canceled the x minus 1, now it's legal to plug in x equals 1. Because now when we plug in x equals 1, we just get 1 squared plus 1 plus 1. We just get 3. And so that means that's the answer. That the whole gist is we want to plug in 1. Sometimes we just have to simplify it first before we plug in 1. But there we go. We get an answer of 3.